There's this entire world of invisible chemistry. It's happening all around us, all the time. I mean, in your kitchen, out in the garden, even inside your own body. So today, we're going to pull back that curtain and take a look. Okay, so you know that feeling, right? After a big, spicy meal, that burning sensation everyone calls acidity. We've all been there. But what is actually going on inside our stomach? And more importantly, what can chemistry tell us about the best way to deal with it? So you're feeling that burn. Now your friend might say, hey, just have some lemon juice. But then your grandmother, she might swear by a little bit of baking soda and water. One is sour, the other's bitter. So which one is it? Well, the answer is all in the science of what makes them so different. All right, let's get into some basic science. How can we tell the difference between these things without, tasting them? Because obviously we're told from childhood, don't taste random things. You see, it all boils down to two main categories, acids and bases. Acids, well, they're the things that taste sour, like lemon juice. And in a lab, they do something really cool. They turn blue litmus paper red. Then you have bases. They're bitter and often feel kind of soapy, like actual soap or baking soda. And their superpower? They do the opposite. They turn red litmus paper blue. It's basically a chemical color code. And you can actually see this in action at home. I'm sure this has happened to you. You get a Haldi stain, a curry stain on your clothes. And when you go to wash it with soap, it suddenly turns reddish brown. Have you seen that? That's not just some random thing. The soap is a base, and the turmeric is acting like a little detective, changing color to tell you that. And it's not just turmeric. Nature has given us this whole detective kit, really. We call these things indicators. So you've got litmus, which comes from the lichen plant, but you can find them in everyday things too, like red cabbage leaves, or even in flower petals from plants like petunias and geraniums. They all change color to tell us if something's an acid or a base. How cool is that? Okay, so now we know how to spot acids and bases, but their real power, their real magic, is in how they react. So let's see what happens when they get to work. Okay, look at this. This is a classic experiment. We have some zinc metal just sitting in a test tube. Now watch what happens when we add some acid. Whoa, instantly it just comes to life. See all that fizzing? All those bubbles? So what exactly is going on? Well, we're catching that gas in some soap bubbles. And now, for the grand finale. We bring a burning candle near one of those bubbles and pop! That little pop sound is the classic surefire sign of hydrogen gas, no doubt about it.
And that pop isn't just for show. It proves a fundamental rule of chemistry. When you mix an acid with a metal, you always get two things, a salt and that poppy hydrogen gas.
All right, now for the most important reaction, especially for our acidity problem from the beginning. What happens when an acid and a base finally meet? Oh, this is where the real magic happens. So to really see this, we need a special indicator. Now watch this. Right now, it's totally clear. But the second we add it to a base, bam, the entire solution turns this amazing bright pink color. Okay, now keep your eyes on this. We're going to take that pink solution and start adding an acid, just drop by careful drop. What do you think's going to happen? And it's gone. The color just vanishes. The solution is completely clear again. What you just saw, that is neutralization. So that's the main idea behind neutralization. An acid and a base, they literally cancel each other out. And what are you left with? Just salt and water. Now think back to our stomach ache. If you have too much acid in your stomach, adding more acid, like lemon juice, is just going to make it worse, right? What you need is the opposite. You need a base, like baking soda, to neutralize all that extra acid and finally get some relief. But it's not always about just acid or base. The strength of that acid or base is super important in our daily lives. And to understand that, we need a way to measure it. And this is how we do it. This is the pH scale. The easiest way to think about it is like a ruler for how acidic or basic something is. It goes from 0 all the way to 14. Right in the middle, at 7, that's neutral. Think pure water. Anything below 7 is acidic, and the lower you go, the stronger the acid. Anything above 7 is basic, or what we also call alkaline. Let's put this into perspective with some everyday things. So lemon juice, super acidic, way down around 2.2. Even your morning coffee is a bit on the acidic side. Tap water, that's usually right there in the middle, around 7. And our old friend baking soda is a mild base, around 8.3. See? Suddenly the scale isn't so abstract. It helps you see the hidden chemistry everywhere. So why does any of this matter? Well, for us, it's literally a matter of life and death. Our bodies have to work so hard all the time just to keep our blood within this tiny, tiny pH range between 7.0 and 7.8. If it goes too far in either direction, our systems just start shutting down. It's an incredibly delicate balance, and it's what keeps us alive. And this balance isn't just important for our bodies. It's crucial for the entire planet. For example, when pollution makes the pH of our rainfall below 5.6, we call that acid rain. And when that rain gets into our rivers and lakes, it can throw the whole ecosystem out of whack, making the water too acidic for fish and other creatures to survive. It's all a very fragile system. So there you have it. From the pop of a gas bubble to a curry stain on your shirt, all the way to the delicate balance inside our own bodies, this invisible chemistry is absolutely everywhere. And once you know the language, you start seeing it all the time. So I'll leave you with this question. Now that you know the secrets of acids and bases, what invisible reaction will you notice next?